Hello students, let us start from numerical 7 onwards of exercise 11b. Seventh numerical, a piece of ice of mass 40 gram is added to 200 gram of water at 50 degrees Celsius. Calculate the final temperature of water when all ice has melted. So here we have ice, initial temperature of ice is not given. So we must take its initial temperature as 0. Ice first melts, heat energy absorbed is ml, and the temperature of this water increases up to some final temperature T degree Celsius. So heat energy absorbed is mc delta T. So ml plus mc delta T here is heat absorbed. Okay, that is the heat absorbed. And this heat energy absorbed comes from some hot substance. So that hot substance is nothing but water at 50 degrees Celsius. So water at 50 degrees Celsius, temperature of that water decreases to 0. Heat energy released for that process is mc delta T. Sorry, not 0, it will be some final temperature T degree Celsius, right? We can't say it is 0 degree Celsius. Yeah, at the end, after calculation, if it comes out to 0, then it's a different matter altogether. But we cannot assume from the beginning itself that the final temperature is 0 degrees Celsius. Okay, so here this is the heat energy released. mc delta T is heat energy released. So here we are mixing two things, so we can say according to the principle of calorimetry, heat lost is equal to heat gained. Heat lost mc delta T of hot water is equal to ml plus mc delta T. Right, mass of hot water is 200, specific heat capacity is 4.2, delta T is 50 minus T, 50 minus T is equal to, let us take m common from the right side. So 40 gram is the mass of ice, L is 336. Say I am taking 336 in joule per gram, right, because mass is given in gram. Specific heat capacity is 4.2 into delta T is T. 1010 cancel, 20 twos are 40 and 21 twos are 42. So this is 21 into 50 minus 21 times T is equal to 336 plus 4.2 T. 21 into 50, 105, 0 minus 21 T is equal to 336 plus 4.2 T, that is 1050 minus 336 is equal to 4.2 T plus 21 T, that is 25.2 T. So from here we can make T as a subject, right? So 1050 minus 336 is 714 upon 25.2 is equal to T. So final temperature is 28.33 degree Celsius. Eighth numerical. 250 gram of water at 30 degrees Celsius is contained in a copper vessel of mass 50 gram. Calculate the mass of ice required to bring down the temperature of vessel and its contents to 5 degrees Celsius. Okay, so here see, till previous numerical there were only two substances. When we mixed certain number of substances, we were limited to only two. But in this particular numerical, there are three substances mixed together. Okay, So first let me list down. We have water at what temperature? 30 degrees Celsius. Where is this water? It is contained in a copper vessel. In a copper vessel. So let me write copper here. Now what is the temperature of copper? That must be initially same as the temperature of water. Okay, so temperature of copper is same as temperature of water, 30 degrees Celsius. So remember, in the numerical you will be given only either the temperature of copper vessel or the temperature of water, not both. Mass of water is 250 gram, mass of copper is 50 gram. Calculate the mass of ice required to bring down the temperature of the entire mixture to 5 degrees Celsius. So final temperature is 5 degrees Celsius. What is mass of ice? That is what we want to find out. And what is the initial temperature of ice? As we know, if not given, we always take 0 degrees Celsius as its initial temperature. Specific heat capacity of water is given, specific heat capacity of copper is given, and specific latent heat of ice is also given. Fine. So now there are two hot substances, right? Water and copper are hot substances and ice is the cold substance. So we are mixing hot and cold substance. So we can write the statement that the principle of according to the principle of calorimetry, heat lost is equal to heat gain. Okay, heat lost is equal to heat gained. Now, heat lost. Water loses heat energy, copper loses heat energy. So mc delta T of water plus mc delta T of copper is equal to heat gain. Now who gains the heat energy? Ice. But initial temperature of ice is 0 degrees Celsius. So first ice will convert into water, right? Its state will change, ml, and then the temperature of that water increases up to some final temperature which is 5 degrees Celsius. All right. So mass of water is 250. Let me write here 250. Specific heat capacity of water 4.2. What is delta T for water? Initial temperature 30, final temperature 5. So 25 plus mass of copper 50 gram. Specific heat capacity 400 upon 1000 or 4 upon 10. See, specific heat capacity of copper is 400 in joule per kilogram, but mass is given in gram. So we must convert specific heat capacity into gram. 400 upon 1000, right? 400 upon 1000. So that will give us 4 upon 10 into temperature difference 25 is equal to mass of ice, that is what we want to find out. So I will take m common from the right side. L is equal to 336 plus C 4.2 into delta T is 5, right? Because this is MC delta T of what? MC delta T of cold water at 0 degree Celsius. So when the temperature of cold water increases from 0 to 5, of course, delta T is 5 degrees Celsius. Okay. So 0 and 0 gets cancelled. Here also 0 and 0 gets cancelled. And 5 twos are 10 and 21 twos are 42. So now, can we do any further calculation? No. So this is 25 into 25, 625 into 42 plus 5 fours are 20 and 25, 20 into 25 is equal to m into 336 plus 21. So once again now you will have to use your mathematical skill to figure out what will be the answer of m, and that is 74.93 gram. Okay, 74.93 gram. All right, next question. Ninth. 2 kg of ice melts when water at 100 degrees Celsius is poured into a hole drilled in a block of ice. So what is the mass of ice? 2 kilogram. And ice melts when water at 100 degrees Celsius is poured into it. What mass of water was used? Okay, this is typo. What mass of water was used? Given specific heat capacity of water is 4200 joule per kg Kelvin and specific latent heat is 336 into this is 10 to the power 3 joule per kg. So what mass of water was used when ice melts? So ice just simply melts 0 to water at 0 degrees Celsius, and this heat energy ml comes from hot water at 100 degrees Celsius. So temperature of that water drops from 100 to 0 degree Celsius, and that is mc delta T. So this question is very simple, right? According to the principle of calorimetry. See here in the question it is given that how much mass of water is used to just melt the ice. So from there we can conclude that the final temperature of the mixture is 0 degrees Celsius. Ice just melts. Nothing happens to that converted water further. So ml is equal to mc delta T. Mass of ice 2 kilogram. Okay, that is given in kilogram. So we can take the value of L also in kilogram. 336 into 10 raised to 3 is equal to mass of water we want to find out. Specific heat capacity now we have to take 4200, right, in joule per kilogram into delta T is 100. So two zeros here, 1 2 3 zeros, 1 2 3 zeros cancel, and mass is equal to 2 into 336 upon 42 like this. Let me write it this way, 2 into 336 upon 42 into 10. The answer is, why did I do that? Because 42 times 8 is 336. So 16 upon 10, 1.6 kilogram. Okay. So after writing this particular step, it must strike to you, or it should strike to you, that okay, if I divide this 420 into 42 and 10, and then 42 times 8s are 336. So such information, such small no information knowledge will help you to solve numericals very easily. 10th, calculate the total amount of heat energy required to convert 100 gram of ice at -10 to completely into water at 100 degree Celsius. So ice is first at -10 degree Celsius. Easy question, right? -10 degree Celsius, temperature of ice will increase to 0. Then its state will change. Ice to 0 at water at 0. Water at 0 to water at 100 degree Celsius. Ice at -10 to ice at 0, that is mci delta T. Ice at 0 to water at 0, mc ml. Sorry, this is change in the state, so only ml. And then water at 0 to water at 100, so mcw delta T. So when I add these three, mci delta T plus ml plus mcw delta T, that will give us the total heat energy absorbed. Okay, I can take mass common first so that calculation becomes little easy. Ci 2.1 or 21 upon 10. Delta T is 10 plus L is 336 plus Cw is 4.2, 42 upon 10 into 100, 0 0 cut, 0 0 cut. So this is 100 into 21 plus 336 plus 420. 420, that is 336 plus 420 plus 21, 7, 77700 joule. This much heat energy is required to convert ice at -10 to water at 100 degrees Celsius. Next question. The amount of heat energy required to convert 1 kg of ice at -10 to water at 100 is 777,000 joule. Calculate the specific latent heat of ice. Okay. So once again, it is same as the previous question, right? Ice at -10 degrees Celsius. First, the temperature of this ice will increase to 0. So we can say MCI delta T. Ice at 0 to water at 0. So ml. And water at 0 degree Celsius to water at 100 degree Celsius. MCW delta T. And this total heat energy absorbed is already given to us. So Q is equal to M Ci delta T plus ml plus mcw delta T. Q is 777,000. Let us take mass also common and into the bracket. Now let me directly put the value. Mass is equal to 1 kilogram. Specific heat capacity of ice is 2100 into delta T is 10 plus L we want to find out plus specific heat capacity of water is 4200 into 100. Okay, so this is 21000 plus L plus 421234 zeros. So L is equal to 777,000 minus some number, that is 421234, and this is 00021, 0000144, and this will be 336000 joule per gram. Okay, 336000 joule per kilogram, not gram. Okay, because mass we took in kilogram and specific heat capacity values also we considered in kilogram. So L unit must be here joule per kilogram. And finally, we are on the last question of this exercise. 12th, 200 gram of ice at 0 degrees Celsius converts into water at 0 in 1 minute when heat is supplied to it at a constant rate. Now, when heat is supplied to it at a constant rate, meaning continuously per second, certain fixed quantity of heat energy is supplied. In how much time 200 gram of water at 0 degree Celsius will change to 20 degree Celsius? Okay, so here first ice at 0 degree Celsius changes to water at 0 degree Celsius. In how much time? 1 minute, or we can say 60 seconds. What is the formula to find out heat energy absorbed here? ml. So we know ml, okay, or we can calculate what is this heat energy. Time is given and this ml upon T will give us power. Okay, so this power is nothing but heat energy supplied at constant rate. Power is equal to ml upon T. Alright, let us not calculate power as of now. Let us read the question further. In how much time 200 gram of water at 0 degree Celsius, water at 0 degree Celsius will turn or will change into water at 20 degree Celsius? What is the formula here? mc delta T. And in how much time does this happen? Now, whatever is the power that we calculate in the first part, the same must be the power in the second part. Okay, so here power is constant, that is q upon t in the first case and q upon t in the second case. These two powers are same. Q upon t in the first case is ml upon t, and this is mc delta t upon t. Let us substitute the values now. Mass of ice on the left side is 200 gram. Specific latent heat is 336 upon time 60 seconds is equal to mass of water 200 gram, specific heat capacity 4.2 or 42 upon 10, and delta T is 20 upon time T2 we want to find out. 200 gets cancelled, 10 gets cancelled. So now T2 is equal to 84 into 60 upon 336. 84 4s are 336. 60 upon 4, 15 seconds.
Thank you for watching. Please check the link in the description below for more numerical videos. Please like, share and subscribe to my channel.